Hello, and welcome to Part 2 of Getting Started Guide for the GEMS Comprehensive Pile Foundation software developed by Geotechnical Engineering Modeling Software, GEMS. Piles are used to provide foundation support to wide-ranging structures such as buildings, bridges, wharves, jetties, and towers. The GEMS Comprehensive Pile Foundation Analysis software supports analysis of land bridge and waterfront piles. The software includes modules for pile capacity estimation, axial load analysis, and lateral load analysis. The software includes both linear and nonlinear methods of analysis. Various common procedures for analysis used in practice are included in the package. The software is available for a 30-day trial download from our website for Windows and Macs. One can also try the online cloud version for 30 days from our website using a browser. If you haven't installed a copy yet or signed up for a cloud account, this may be a good time to do so. Visit our website https://www.gemsoftware.org. This is a two-part video. In the first part, we went over the application, defined pile dimensions, properties, and soil parameters, and estimated the capacity of the pile. In the second part video, we will apply axial loads and lateral loads on the pile head and perform axial and lateral load analysis of the same pile. We will start from where we left off in part 1 video. We have a bored, full circular pile 10 meters in length having a diameter of 0.5 meters. The pile is constructed with M30 concrete. The pile head is not free to rotate under lateral loads. The soil consists of 3 layers: soft clay 3 meters thick, stiff clay 3 meters thick, and a sand layer 6 meters thick. We will use some typical properties for each layer for the sake of this demo. These would normally come from the soil investigation report. We will use API 2011 as the method for axial and lateral analysis for each of the soil layers. We will try 2 loading scenarios. Load case 1, an axial load of 500 kN and lateral load of 100 kN applied on the top of the pile. Load case 2, an axial load of 750 kN and a lateral load of 200 kN applied at the pile head. Let us start again with the project properties pane. We will edit the description to add details for the loading scenarios for our records. Select the axially loaded pile analysis and laterally loaded pile analysis checkbox. Next, set the number of load cases to 2. Next, we will look at the input parameters. Pile dimensions. We had set the pile type as a bored pile with a circular cross section, a length of 10 meters, and a diameter of 0.5 meters. Pile properties. We have set the pile material as M30 concrete. The pile head is not free to rotate under lateral loads, and the rotation angle is set as 0 radians. Soil properties. Let us review them quickly. Soft clay layer. One can select the axial and lateral analysis methods from the drop-down menu. We will keep the axial and lateral analysis methods as API 2011. There are few more required parameters for this analysis: J constant, epsilon 50, and R constant, which we will leave for now as default values. Stiff clay layer. Similar to the soft clay layer, we will leave the axial and lateral analysis method as API 2011. Sand layer. The choices for axial analysis method and lateral analysis methods are different, and we will again leave them as API 2011. We are using default values for the sake of convenience. One must use values from the soil investigation report for all of them. Let us now visit the Load Cases tab. You will see two tabs on the right hand side, Load Case 1 and Load Case 2, which have been added. We will enter the load case data in the respective tabs. Load Case 1, Load Case Description, Axial load of 500 kN and lateral load of 100 kN. You can choose to include self-weight in axial analysis if you wish. We will leave it as it is. Next, set the axial load as 500 kN and lateral load of 100 kN. We don't have a lateral moment, so we will leave it as 0. Our loading type will be static loading. You will see the loading diagram has been updated with the details we have entered. Let us similarly put the data for load case 2. Load case description, axial load of 750 kN, lateral load of 200 kN. Set the axial load as 750 kN and the lateral load as 200 kN. Let us see if our inputs are valid and there are no errors in them. From the menu bar, click on Compute, Validate. We now see that our inputs are valid. We have entered all the required information for getting our pile capacity, axially loaded pile analysis, and laterally loaded pile analysis. Now let us click Compute, Compute. We get notifications indicating successful completion of the analysis. Click on the axially loaded pile analysis pane to view the results of the axial analysis. Axial loaded pile analysis pane consists of 3 tabs, namely Axial Analysis tab, which contains the results of the axial load case analysis for all the loading scenario, TZ tab, which consists of the TZ curves, and the QZ tab, which consists of the QZ curves. In the Axial Analysis tab, the pile displacement table details the pile head displacement, pile base displacement, and status of execution for each of the load case, along with the axial load applied. OK status indicates that our analysis completed properly without errors. The corresponding pile head displacement graph plots the vertical displacement of the pile head for each of the loads applied. Similarly, the corresponding pile base displacement diagram plots the vertical displacement of the pile base for each of the loads applied. We see that for the 500 kN load, the pile head displaces by 2.45 millimeters, and for the 750 kN load, the pile head displaces by 5 millimeters. The axial force table contains the axial force experienced by the pile at various depths for each of the load cases. Each column in this table represents a separate load case. The first entry in the table corresponds to the loads applied at the pile head. The corresponding axial force diagram plots the axial forces experienced by the pile along its length for various loads. Each curve represents a load case indicated by LC. The axial stress table contains the axial stress experienced by the pile at various depths. Each column again in this represents a separate load case. The corresponding axial stress diagram plots the axial stress experienced by the pile along its length for various loads. Each curve again is represented by a load case indicated by LC. The axial displacement table contains the pile displacement at various depths. Each column in this table represents a separate load case. The first row represents the pile head displacement, while the last row represents the pile base displacement. The axial displacement diagram plots the axial displacement of the pile along its length for various loads. Each curve represents a load case indicated by LC number. In addition, the application also displays the TZ generated at various depths in the TZ tab and the QZ curve generated at the pile base in the QZ tab. Click on the laterally loaded pile analysis pane to view the results of the lateral analysis. Laterally loaded pile analysis pane consists of the following tabs: PY static, which contains the PY tables and curves for static loading; PY cyclic, which has the PY tables and curves for cyclic loading; load case tabs, multiple load case tabs displaying the analysis for the corresponding load cases. We will focus our attention on the load case tabs. Each load case analysis tab consists of tables and graphs tabulating the lateral analysis results for the load case. The summary table tabulates the absolute maximum values of lateral deflection, bending moment, shear force, and soil pressure and the depths at which they occur. In our case, we have a maximum lateral deflection of 4.6 mm, bending moment of 174.7 kN/meter, shear force of 100 kN at the pile head, and a maximum soil pressure of 93.5 kN/meter at a depth of 3.2 meter. Next, we have the deflection, slope, and pressure table, which contains the lateral deflection, slope, and soil pressure experienced by the pile at various depths. Since we said the pile head is not free to rotate, we can see the slope at the pile head is 0 radians. The shear bending moment table contains the shear forces and bending moment experienced by the pile at various depths. Each point represents a node in the finite element analysis. Lateral pile analysis diagram plot the contents of the analysis tables. The lateral deflection diagram plots the horizontal deflection of the pile at various depths. Shear force diagram plots the shear forces along the length of the pile. Bending moment graph plots the bending moment experienced by the pile at various depths. And finally, soil pressure diagram plots the soil pressure along the length of the pile. Similarly, we have the results for the second load case. The lateral load being higher, we see the pile has experienced more lateral deflection. One can then export the analysis results to Excel and Word if required. File, export to Excel. And file, export to Word. As you can see, the application is intuitive, versatile, and very easy to use. To summarize, in this video, we enabled axial and lateral analysis in the project pane, reviewed the pile dimensions, properties, and soil properties, added two loading scenarios, and performed axial load analysis and lateral load analysis on the pile. If you have queries, please email us at support@gemsoftware.org. Do like this video if you found it informative. Subscribe to this YouTube channel to stay appraised of our upcoming videos and product releases, and share this video with your colleagues. Thank you for watching.